So in your notes packet, just like the typical notes packets, the first page is all vocabulary. If you want to go back and fill that in and use that to study for your test, that is your right. I don't spend a lot of time going back and filling those in. It's sort of there if you want it. If you don't use it, feel free to skip over it. But today we're doing the first section of the chapter. It's all about classifying triangles. So first, let's just define what a triangle is. A triangle is a figure formed by three segments joining three non-collinear points. That basically means that the 3 points can't be on the same line. If they're on the same line, you just end up with an extra long line, right?
This packet's too big.
I know.
It's just too much.
All right. So go ahead and write that one down. Then we'll talk about different ways to classify these things. Okay, so there are two ways to classify triangles. You can do it by the side length or you can do it by its angle measures. So first we'll talk about side length. If all of the sides are congruent, that's called an equilateral triangle. So you have a little box in your notes. Equilateral, add that they're all congruent. And then you can mark them right in the diagram in the same manner. This is a way to show that all these segments are congruent, or you can give them all the same label. The next one, you are right, is isosceles. Isosceles means at least two congruent sides. So if two of them are congruent, it's isosceles. If they're all different, it's called scalene. So you can add that information. None of them match. Scalene. I know, it's a weird... I feel like I should have a memory trick for these, but I don't. So if you come up with one, let me know. Equal, though, like they're all equal. That one's kind of easy. But as far as isosceles and scalene, I'm not sure. Maybe this one has two S's and two of the sides are the same. One S, none of the sides are the same. Oh, it has three S's. There you go. I don't know. Memorize it.
That really sucks.
I'm sorry. So when you classify them by angles, there's actually four options. The first one is equiangular. When three of the angles are congruent, it's equiangular. So they can all be marked congruent, or you can know that they're all 60 degrees. 60 degrees is the only one that will ever be equiangular. Like you can't have a triangle where they're all 50 degrees or something. 60 is the magic number. And you'll learn more about why that's the case as we go on with triangles. But just for now, know that they can be marked congruent or they can all be marked 60. That's equiangular. If they're all marked acute, it's an acute triangle. That you can go by looks as well. It's pretty easy to tell when they're all acute. Right angle, though, right triangle, if you see the little box anywhere, it's a right triangle. It's impossible to have more than one right angle in there. So if one's right, it's a right triangle. Same for obtuse. You would only have one angle that's an obtuse angle. That automatically makes the whole triangle an obtuse triangle. So here's example A. I want to classify it by side. So those are the first three things we talked about. They're all the same. They're all 7. It is equilateral. You're right. All three are congruent. It's an equilateral triangle. All right. Part B. Are any of those the same? So it's called scalene. And part C, we have 8, 8, and 2. So 2 of them match. Scalene is none of them match. Okay, we can go back in a minute. This one is isosceles. So when 2 of them match, we call it isosceles. Any questions? Now we are classifying by the angles. So that's the second chart in your notes. Things like equiangular, acute, obtuse, right. That one is right. Good. Once you see one right angle, it is a right triangle. Yeah, this is an obtuse triangle. Now, if two of them are 60, spoiler alert, the other one's also going to be 60. So this would be a what? Equiangular. Good. Questions? All right, now we're going to do both. So by sides and by angles. It's an isosceles. Acute. Good. Acute isosceles. If you put isosceles acute, that's fine. The next one. I feel like there's something you should have known before we started these. I will just ruin the surprise for you. If the other two add to 90, the third one is also 90. So you can go ahead and add that box. So this is a scalene right. And then part C. Scalene and obtuse. Very good. There's one angle that's larger than 90. That's why it's obtuse. There are three sides that are not the same. That's why it's scalene. Any questions? No. Next, we're going to talk about the definition of a vertex. The vertex is a point that joins two sides of a triangle. When you are naming a triangle, we use all three. The plural for vertex is vertices. So we're going to use all three vertices when we are labeling or naming a triangle. Okay, and then the last thing, the side opposite the angle typically has the same name as that angle. I'll show you that in just a second. So let's just say, we'll keep it easy. If we have angle A over here, oh, that's going to cover it up. Let me draw it over here. So I'm just going to move that triangle over here. So if we have angle A and angle B and angle C, the side across from the A is usually called A. The side across from B is usually called B. The side across from C is usually called C. So when we say opposite side, it's the side across from the angle. So if I said the side opposite angle C, you'd go to angle C, you'd go across, it would be this one. Now, sometimes these little letters won't be there. If they're not there and they say, like, what's the side opposite side C, you would just say AB. Okay? If they would say the side opposite A, you would say you need two letters for a side. BC, good. So sometimes you'll see it how I had it originally with the lowercase letters across. If those aren't there, you can't add them. You can't use them to name the side. You just have to go with the segment that's there. Okay? So the sides of triangles are segments, and we use the vertices, the endpoints, to name them. And just so we're clear, this would be triangle ABC. Okay? And the side across from angle A is side BC. The side across from angle B is side AC. The side across from angle C is side AB. All right. Use the triangle below to name the side that is opposite the given angle. So aside from angle A is side CB or BC. It is a line segment, so put the segment symbol on the top. Now, had there been a lowercase a there, we could have called it side A. If it's not there, though, you can't add it. All right. What's across from angle B? CA or AC. Good. Make sure you have the segment symbol. Make sure you're using 2 capital letters. And what's aside from angle C? Side AB. Good. What questions do you have? Okay, so chapter 4 section, what I would call a relatively easy section. So I'm going to give you guys your homework. I'm going to give you about 10 or 15 minutes to do it. Then we're going to spend some time going through that chapter 3 test because it wasn't the greatest thing I've ever seen in my life, okay?